Okay, hi everyone, my name is Dan. Thanks for everybody turning up, it's a great turnout. I'm not from here, as you can probably tell by my accent, and I have a slight cold, so if I start making some tea or sneezing over everybody, then I do apologise for that. I'm going to get straight to it. The title of my talk is called Do You Really Need All That Prompt? And I basically wanted to inspire you to build AI tooling, but also just to be careful in how much prompt you actually send into the large language models. So I'm going to be showcasing this small tool that lets you build GraphQL queries from plain text. And then I'm going to talk you through some of the problems that we face with building this, and how we use Neo4j, the graph database, to fix some of the problems that we faced. So I've got about 9 minutes left. Side note, I thought I'd put this in here just to inspire people, that pretty much anybody can work with AI now. All you need is an API key and the ability to talk to like a REST API or some form of SDK. So here you have the Python and the TypeScript in there. So as long as you can build a prompt, not a very big one, of course, as you'll learn after this talk, you can just start hacking away. So GraphQL Plain Text. Who's working with GraphQL here? Okay, just two of you. Okay. Well, GraphQL is basically an API that has a schema against it. And what we can do with the tool that we've built called GraphQL Plain Text is you can pass in the schema of your API into this client. And then you have this interface where you can issue plain text queries, and then it will resolve that plain text query into a relevant GraphQL query. And under the hood, what it basically does, contrary to the title of this talk, is that it builds one giant big prompt. And you'll see, in the middle here that we've kind of tried to do some optimizations in terms of compressing the GraphQL schema. But essentially, the only thing that we settled on was stripping the white space away from the schema. So it wasn't really that practical at production and at scale. So you can see here that this is like an extract from the GitHub GraphQL API, and it's pretty big. So even if you just compress that schema and send it to your large language model, it's still going to be pretty much unusable. So before and after this compressed type defs, our library was completely unusable with the GitHub API. So this is a pretty bad idea. You're training the large language models on your entire schema, so this could be leakage of your business secrets, and you're wasting resources, and it's more likely that the LLM is going to hallucinate. So we need a better solution. This is where Neo4j comes in. So it's a graph database, and it has support for vector embeddings, and it's proven over the last 10 plus years that it's hyper efficient at traversing relationships and also vector and text search. So we can kind of put this in front of our prompt creation to let us generate these queries with more precision. So here's like an extract schema that just has, two queries in there, logins and users. There's nothing that extravagant about this. What we want to do, we want to upload our schema to Neo4j so that we can use a RAG approach when querying it. So here this pseudocode is basically for every single type and every single field in our GraphQL schema. Let's create an embedding, and then let's store that in Neo4j. And on the right-hand side here, you'll see that this is Cypher, the query language, and highlighted in yellow, you have the embeddings that are actually put into Neo4j. And this is kind of like building a one-to-one mapping of our GraphQL schema to the storage layer in Neo4j. And it looks like that. So this is like the whiteboard model of Neo4j that we have, and you can essentially visualize your data in a much better way. So if we go back to the beginning, where you issue a plain text query into the client, what we want to do first is we want to use the proven techniques that we already have to search the database and find a subset of that schema that's relevant to that plain text question. And then we can mash that together and have a partial schema that we can ultimately send to our large language model that's going to be a lot more precise and it's also going to reduce the chances of hallucination and just wasting extra resources. So the way that we do that, once we have our vector store in place, is we can use some of Neo4j's graph data science libraries. And this one's using the similarity concise. And I've put a link to that in the docs that you'll have access to. And it's basically looking at all the vectors that I've created, and it's comparing it against the plain text string. And then it's giving me all the schema fragments that are relevant to that plain text string. And then it looks like that. So it kind of, find all usernames, let me find all the relevant parts in the graph, and then I can reduce that down into a small schema and then provide that to whatever tool. Maybe it's GraphQL Plain Text, maybe it's another tool that you have. So, the moral of this is really, do you really need all that prompt? We have a lot of tools that are already available to us that we can narrow down our search using fuzzy search or vector search or full text search or whatever search you have. So, rely on those before you just give all of your data to the large language model. And Neo4j is a great choice for this as well. So if you're hacking away today and you feel like you're creating a big prompt, then maybe ask yourself if you can use another solution in front of that. Here's a quick one as well. I know that some of you are going to be hacking away with Hypermode today. I actually built a GQL PT Modus. So if you are building a Modus GraphQL API, you can basically hook it up to GraphQL Plain Text and talk plain text to it, which would be pretty fun. And also, sorry, I need to get the photo of that. This link is also in the docs as well. Also, if you're interested and you feel like your company would be interested in talking to your data, then we're actually building a platform. So it's at preview.apipt.dev, and it has all of this RAG AI generated queries and team workspaces enabled in it. Thank you very much for your time.